The purpose of this video is to help teachers understand why place value is harder than we think. So this is not meant to be used with students. This has been adapted with permission from Dave Martin's Elementary Math Anything But Elementary session that he did at the McCata Conference in 2019. Let's count on our fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 fingers, which are also known as digits. That term may sound familiar to you. We also refer to the digits in a number. But what do we mean when we say 10? What we're really saying is that we have one full set of digits and we have 0 extra digits. So from now on, I want you to use that language when you're thinking through this activity. One full set and 0 extra. So what would come next? Remember, don't say the number, but say the phrase. Well, I can see that I have one full set of digits and I have 1 extra. What about this number? Well, I have one full set of digits and 2 extra. One full set of digits and 3 extra. But that's if we live on Earth. What about if we travel to Mars? So when I take a look at this Martian, what do I notice about the Martian's digits? I can see that a Martian only has 3 fingers on each hand, so a Martian has 6 digits altogether. So in the Martian world, the numbers 6, 7, 8, or 9 won't mean anything to them. They won't have a numeral for that. So for the rest of this activity, you are not allowed to say the numeral or number 6, 7, 8, or 9. So let's count together. Remember, everything we do is on Mars. 1, 2, 3, 4, 5. What would come next? I'll give you a moment to think about that. I have one full set of digits and 0 left over. So the number would be 10. How many full sets of digits do I see? And how many extra? I can see that I have one full set of digits here. And I can see that I have 3 and I can see that I have 3 extra. And I can see that I have 3 extra. So my answer will be 13, one full set and 3 extra. Try this one. I can see that I have 2 full sets and 3 extra. So my number is 23. Try this one. I can see that I have 1 full set and 3 extra. So my answer is 13. How about this one? I can see that I have 1 full set, 2 full sets, 3 full sets, 4 full sets. So I have 4 full sets and 0 extra. So I have 40 fingers in all. Take a moment to try this one. So it looks like I have 4 partial sets. But if I take one from that last 10 frame and put it into the first one, there's a full set. If I take another one from the last 10 frame and put it into the second 10 frame, there's a second full set. Then I can take a third one from the last 10 frame and put it into the third 10 frame, and I have another full set. So I will have 3 full sets and there will be 1 left over. So my answer is 31 dots altogether. So now you're in a math class and you're being asked to add, keeping in mind that these are Mars questions. So these are numbers on Mars. Take a moment to answer the 3 questions. And then I'll have 3 left over. So 1 full set and 3 left over is 13. Take a look at this one. How many full sets? How many extra? How many ones or how many fingers are there altogether? I can see 1 full set, 2 full sets, 3 full sets, 4 full sets, 5 full sets, and 1 extra. So my answer will be 51. Now what? Well, I had 51 and I just increased it by 1. So now I have 52. And this one? 53, because I increased it just by 1. This one? 54. 5 full sets, 4 extra, 54 fingers altogether or 54 ones altogether? 55. And now take a moment to think about this one. Did you say 6 full sets? Remember, that doesn't make any sense to a Martian because they don't use the number 6. So what might that look like? Well, we have 10 tens here. 1 10, 2 tens, 3 tens, 4 tens, 5 tens, and the next number after 5 is 10 tens. And 10 tens is equal to 100. Well, we have 10 tens here. 1 10, 2 tens, 3 tens, 4 tens, 5 tens, and the next number after 5 is 10 tens. And 10 tens is equal to 100. Now, you may have struggled with that a little bit. That's because research shows that students have significant difficulties when moving beyond 2-digit numbers. We think that it's a nice, easy move to move from regrouping 10 ones to a 10 and taking that concept and moving 10 tens into 100. But it's actually quite complex, and we rush to that too quickly. So we want to spend lots of time building that understanding of 2-digit numbers before looking at what a 3-digit number might look like. So you'll notice on the previous screen, we called that 10 tens. And I would just do that with kids as well. And I might add another set of 10 on there and say 11 tens, 12 tens, 13 tens to build that sense of the tenness first before attempting to have that conversation about regrouping 10 tens into 100. So try one of these questions. You may want to pause the video in order to give yourself enough time. The first question, 3 plus 5, I can take 1 from the 3 and move it into the 5, so I've got a full set, and then 2 left over. So I have 1 full set and 2 extra, gives me the answer 12. The next one. I can see here, this 11 means I have 1 full set and 1 extra. Some of you may have been thinking about the number 11 on Earth, but you need to be thinking about the number 11 on Mars. So 1 full set, 1 extra, and then I've got 5 extra here. Well, if I take the 5 and the 1 extra from this one, well, that makes another full set. So now I have 2 full sets, plus I have the 4 extra. So 2 full sets and 4 extra is 24. Try the third one. 3 full sets and 2 full sets, well, that'll be 5 full sets. And then I've got 3 here and 4 here. Well, let's take 2 from the 3 and put it with the 4, so I've got another set. So I had 5 full sets, and I have another full set. So 10 tens is 100. I still have 1 left over from here. So my answer will be 10 full sets. 1 extra is 101. For the bottom, there's quite a few different options you have for this. You could go as simple as 10 plus 10 plus 20, or 30 plus 3 plus 3. Lots of different options in there. The next thing that we're going to do is build a 100s chart. Now, in a traditional 100s chart, the 1 is at the top and the 100 is at the bottom right. But we talk about increasing the value of the 1s, or increasing the value of the 10s, or increasing the number. But we actually end up moving down the chart, which is counterintuitive to what we're doing. So we're going to actually create a bottoms up chart. We're going to start with the 1 at the bottom instead. We're just going to count 1, 2, 3, 4, 5, 10. What will the next row look like? 11, 12, 13, 14, 15, 20. And the next row? And just keep counting it out. 21, 22, 23, 24, 25, 30. 31, 32, 33, 34, 35, 40. 41, 42, 43, 44, 45, 50, 51, 52, 53, 54, 55. Now what's 10 tens? 100. Now take some time, pause the video, and look for some patterns. What do you notice? What do you see? What's interesting? What stands out for you? What connections can you make? Remembering that all of these numbers are the numbers on Mars, not on Earth. Some patterns you may have noticed is that as you move from the left to the right, it always has the 1s as 1, 2, 3, 4, 5, 0. 1, 2, 3, 4, 5, 0. Absolutely, that's a pattern. You may have noticed as you go up, as you increase, the value of the tens increases. You can see 1, 2, 3, 4, 5 in the tens place. What's the tens place for the bottom row? 0. So it's actually going 0, 1, 2, 3, 4, 5. You may have noticed that if you start at the 1 and you go diagonally, the 1s is increasing by 1. And the 10s is increasing by 1. Interesting. Lots of different things that you can see going on. Did you notice that if I add the 2 diagonals, 35 and 30, I get an answer? And if I add the 2 diagonals, 25 and 40, I will get the same answer. Now, don't forget to convert that to Mars as you think about that. Lots of different patterns that we may or may not have noticed in the past.